Tonight I want to introduce and welcome Kaeti Stoss. Kaeti is an environmental educational specialist from RIT College of Science. So we want to welcome her, and I'm going to hand it over to Kaeti.
Thank you. So I'm going to share with a lot of the interesting science that's being done at the Rochester Institute of Technology. So we know that plastic pollution is all around us. We keep hearing all these stories about everywhere that scientists look, we're finding plastic. In ourselves, in our environment, in bottled water, in all these places. And so you might be wondering about plastic pollution closer to home. And I know that I have. So my background is in earth science education with a focus on water quality. And a lot of what I care about are things that go with my kids. So there's me with my son, Eric, sampling macroinvertebrates in Irondequoit Creek. And then my daughter, Jo, is with me at Imagine RIT, that's in April, where we open the campus and share all the interesting things going on at RIT. And that's with her looking at it. And then in the bottom is my work on the Genesee River, where I'm showing another macroinvertebrate to a student. And the question that really drives me is, what are the long-term effects of all this plastic in our environment, and what can we do about it? And I myself am not the scientist, I'm not faculty, but I work with a lot of amazing people. And we have a very interdisciplinary team. We have Dr. Ettingas of Chemistry and Material Science, Professor Hoffman for Mathematics and Statistics, Professor Christy Tyler for Environmental Science, Professor Stephen Dick for Biomedical Engineering, and actually the Dean of the College of Science, Andre Hudson, also works with us. His background is biochemistry and microbiology. So a lot of different people are answering these questions here. And we have a large team of amazing grad students that are working on this. And I also like to work with the community. So on the upper left is from our citizen science cleanups that we did with the Boy Scouts and Girl Scouts, where not only did we remove plastic pollution from the environment, but we also sorted it so that we could see what kind of plastic pollution are we finding on the land. And then in the upper right is with Monroe County Soil and Water, their conservation field days, where I work with 18 classes of students in 3 days, and we did I focused our activity on plastic pollution. The lower left was Churchill Child Middle School. They actually used some of the materials that I created and made a whole unit on plastic and microplastic. And then in the lower right, that's at Rochester Child First Network, and this is doing one of the activities of kind of having students who are right now making their own watershed and planning a community for it. So we have a lot of different partners for this. And what actually is plastic pollution? So a lot of plastic pollution is what scientists call macro. This is the big stuff. It doesn't have to be that big, but bigger than 0.5 centimeter. So these are the ones that you've seen from some of the ghost nets from like large fishing operations, the small bits of plastic litter that animals can eat, the sea turtles with the plastic for it. And all this macro pollution will eventually break down and become micro or nano plastic. Will get broken down even smaller. And when we talk about like the great ocean patch that's like bigger than Texas, people sometimes think it's something solid, but it's really more like a soup. That there are these areas because of the water currents in the ocean that gather the plastic from land in the center of the oceans. And plastic is called microplastic if it's smaller than 0.5 centimeter. So think about the size of a grain of rice is often what I use as my metric. And then Scientists are now starting to look at nanoplastic. This is the stuff that is so small, just a few microns. These are the pieces of plastic that are as small as smoke or even bacteria. The news article that made news this week was about how much nanoplastic is in a bottle of water for it. And so we know that the more we look for this, we're finding this in more and more places. And plastic pollution has grown exponentially since the 1950s. So we're all guinea pigs. No one knows the long-term effect of all of this plastic. And originally, when plastic came out, no one thought about what happens after we throw it out. We just thought we throw it out, we don't have to worry about it. And then, starting around the 1970s, people started to care. You get into the creation of Earth Day. And unfortunately, a lot of the plastic companies decided to push that issue onto consumers. If any of you have seen the symbol on plastic of the triangle, there's a reason why it's the same as the recycling symbol. And it doesn't mean that plastic is recyclable. All that number means is it tells us what material the plastic's made out of, not whether or not someone can recycle it. And we know that plastic pollution is growing exponentially. Packaging is the largest use, followed by construction, but most of the plastic that's used in construction tends to be used for long term. Things like the pipes in your walls. You know, you're not getting rid of that constantly. Versus a lot of packaging, you touch it once and then you throw it away. So that's why packaging is such a source of waste. And we know that only 9% of plastic waste is recycled. And a lot of it ends up just being thrown out or burned for fuel. And we know the pandemic made this worse. Disposable plastic at hospitals increased by over 6 times. You have all the different, face masks and gloves, and just 1%, if only 1% of that plastic is improperly disposed of, that's over 10 million items. I'm sure during the pandemic, we all noticed that people had more takeout, the gloves that they had. And a lot of times because people just see plastic as cleaner. So even if it wasn't necessarily safer, people wanted to have things wrapped in plastic. And we use this term plastic to talk about a lot of different materials. So plastic isn't just one thing. There are many different polymers that make up plastic. And then you add different additives to it that make it different colors or strengths or different properties for it. The different types and the sizes of it, the morphology, what shapes they are, the color, and then different toxins that are either included or bind to it. So we use this general term for a lot of different things. And what about in the Great Lakes? So we hear a lot about plastic in oceans, but we know there's also plastic in the Great Lakes. And we started getting more attention in this around 2013. And we know, again, everywhere we look, we're finding it. In the surface waters, in the sediments, rivers, and near shore. We're finding that different types of plastic are located in different places within the lake environment. So denser plastic sinks faster, and so it tends to be found closer to shore. Also, we find different shapes of plastic in different environments. So in the Great Lakes, most of the plastic is this green type is fragments. So pieces of larger items that have been broken down. In tributaries, in the rivers and streams, we find a lot of fibers. Most of those fibers are from us doing laundry, are from water treatment that come out of it. And we know that using kind of similar input models, we're finding that there's about 10,000 tons of plastic that probably comes into the Great Lakes. But when we measure how much is actually in the water, we get numbers that are a lot smaller. And that suggests that there's much more plastic than what we just see floating at the top. And a lot of the research that my team is working on is thinking about where is this other plastic? And so what we found is in the Great Lakes, and I think this would also be true for the Finger Lakes, there's not the garbage patch in the center because you don't have the same kind of currents that you do in the oceans. So most of it gets pushed towards the shore where we live. And what we're finding is when we compare models to when people actually look for them, they usually match this idea for it. And we know that plastic doesn't just stay in one place. All plastic gets degraded by UV radiation from the sun. So the more it's exposed to the sun, the more it'll be broken down. Also, you have wave action. You have animals eating it, moving it around. So there are all these different processes going on. So it doesn't just enter the environment and that's it. And so this is an article that some of my colleagues did. As I said, we're kind of looking in this idea, where does it go? And one of the things we did to look at this is they aged different polymers for 12 months in 4 water bodies. So we did the high density polypropylene, so those were bottle caps. Polystyrene would be like a drink cup. The PET fibers, it's the same material that's in a water bottle, but it's also in polyester. The SBRs are tire dust from ground up tires and PVC pipes. And they were all about 2 to 5 centimeters. And we put them at the surface and also down below. And we looked at them. We compared the pristine, the control, the ones that weren't aged, to 1 month, 4 months, and 12 months. And we did this in 4 locations. A rural pond in the Finger Lakes, a Conesus Lake, that's part of why I included this research, a stormwater pond on the campus of RIT in Henrietta, and at Lake Ontario. And you can see here, you can see a little video of going down. These are what the ones that are in the benthos under the water look like. So you can see how things like to grow around it. So the plastic is also part of the habitat. And we call that thin layer of things growing on it like biofilm. You can see this is what some of the items look like when we collect them. And we find more biofilm in the sites with high nutrients, which was the stormwater pond and Conesus Lake, less in the rural pond in Lake Ontario, and then more, and the samples are more degraded at the surface than down below. And this was looking at how degraded they are. The darker the color, the more degraded for it. And these were the 2 grad students that worked on it. They believe that the biofilm or that the burial in the sediments may have prevented some of the oxidation, may have protected the plastic to keep it from breaking down, which does make sense because if you have that kind of like thick algae layer growing on it, that acts a little bit like sunscreen to protect it from like some of the UV lights and other processes. And then they also looked at the settling, at how heavy it is. So things that are more dense than the water sink, things that are less dense float. And compared to the original settling velocity, we find that a lot of the plastic becomes denser over time, but some of the items, especially in the high nutrient areas, end up actually floating more. So they become less dense. because of what's living on it. I didn't include a slide for this, but one of our other grad students looked at the biofilm and found that different bacteria grow on plastic than what the population is in the wild environment. So it becomes like a little sub-habitat. It becomes an area that different things like to live on than the general normal natural environment. And the location between surface and down below also affected it. And then looking at how do these fibers change the metabolism of how much life is in the soil, we're finding that that there was more oxygen, there was less oxygen used when we add the fibers, but when we took the sediment, the sediment that was aged and added to the sediment, that there was more, which makes sense because of that biofilm, that you're adding more organisms to it that's being used. But when we look at worms, if we add earthworms, they increase the overall oxygen consumption, which makes sense because we're adding an animal to the experiment. But when we add the fibers to the worms, they use less. There's less life happening in that sample. They're breathing less, they're eating less, they're moving less. They're doing all these processes. So we know that plastic affects what can live in an area. And then also, how do organisms, aren't just affected by the plastic, they also affect the plastic themselves. As I said, they move the plastic through the environment when they make their homes, when they may eat things that are in the soil, when they get rid of waste with things in the soil. And so seeing how organisms rework the sediment, move the dirt under the water around. And this was an experiment done by another one of our students, who again looked at the polyester fibers and particles, and again used earthworms for this, and looked at 3, 7, and 14 days for it. And so what they found is after 3 days, you're noticing when you added the worms that you're getting the plastic is being found. So the little orange is where they found the plastic. The little pink squigglies are supposed to be like the worms in it for the diagram. That you're finding more plastic deeper in the soil column, that the worms are moving it down. And then the student Paige also got some, I don't know the proper term for it. It's this clear crystal that absorbs water that gardeners put into potting mix to hold more water in the soil. If you use just the mix and don't add it to soil, it acts like clear soil. So it makes it a lot easier to see what's going on. So the orange is actually the plastic fibers. And you can see with this one how the worms are moving it down through the process. They're working it through the sample. So we know that the watershed entry points affect what happens to it. The location determines how it degrades, how fast it sinks, whether it goes into the sediment or comes out of the sediment. Different plastics react to toxins in the environment. They can actually grab onto them and hold more of it. They can impact the ecosystem functions and also just the overall benefit community structure, just what's living at the bottom of a lake. And so we're trying to answer, like, is the location more important than the type of plastic for it? And this is the research that I'm most connected with right now, is how does this plastic enter our environment? Where does it come from? And how does it vary with different land use, population density, and stormwater? And Trying to stop plastic pollution is a very hard problem, but are there any hotspots that we can identify that if we target those, we can have a large impact that can make it worthwhile? And then what are also the most common plastic products? Is there a way we can target certain behaviors? And what can we do about it? And one of the things we're looking at is stormwater infrastructure. So in Lakeville and in a lot of the suburbs outside of Rochester, we have a separate storm sewer system where anything that goes down the drain goes directly into the stormwater runoff, goes directly into the body of water. So it goes directly into Conesus Lake. I saw the sign when I pulled up in the parking lot that said, you know, take care of the area around here. We're in the Conesus Lake watershed. All areas except for, like, I think the northwest portion of this town goes a little bit to Lake Ontario, just based on the relief of the land. But most of the area around here, any plastic that's on the road or on the sidewalk, if it goes down the storm sewer, is going to end up in Conesus Lake. In Rochester, a lot of it will end up in Arundecoit Creek or the Genesee River. And what a lot of Rochester has is something called a combined sewer system. And what this means is that the stormwater and the sewer from your house and any businesses all go to the wastewater treatment plant, which sounds good, unless you have a lot of rain, and that can overload the system. And then that mixture of stormwater and sewer and the sewage can enter the environment directly. Now, some of you may know the history of Rochester and know that we plan well, and we used to have a subway. And that's part of the reason why Rochester has about 30 miles of really large tunnels that acts as storage for our extra overflow water. So Rochester has less of an issue with this overflow than other cities with this system for it. It's only been, I was looking at the data since 2021. It was around 20 times where this has happened for it versus some other systems had a lot more for it. And you can actually sign up for New York alerts to be told when there's a sewage discharge in your area, which can be important if you're someone who wants to do fishing or boating and you want to know what's going on in the water for you. You can sign up at the county level for it. I just found out about that recently, so I just signed up for it. And here's the map for in Rochester. The blue areas are the combined. The red and green areas are the ones that have the separate sewer system where it drains directly. So as I said, most of the city is the combined, but usually right around the Genesee River, there are the areas that go right into the river. And so we're trying to see what's the difference between this? What kind of debris are we finding? And then what's the effect from this? And we're sampling with 3 different methods. One of them are lithotraps, which are looking at the storm drains themselves. The other one is a trawl, which we're looking at the small streams to see what plastic's in it. And then finally the sea bins, which are in Lake Ontario. I'm going to talk about all 3 of these in more depth. And these are some of the locations for these devices. And the sea bin, this is like a trash skimmer. It's like a pool skimmer. That it actually has to have electricity. It sucks water in, and it has that yellow mesh basket in the middle. And then every so often you have to take it and empty it. We're having our students collect it and sort it to see what we're finding. On the upper right, you can see an example of some of the plastic we're finding. And then in this large picture, you can see my colleague Nathan had to put on his wetsuit because these things break a lot. This device, we need some good engineers to make a better one. What often happens is either they get unplugged or the electricity so they don't work, or sometimes they end up sucking themselves down in the muck, in which case my colleague had to put on his wetsuit and pull it up from the muck at the bottom of Lake Ontario for it. So we're getting some data for this, but there's some issues, as I said, with this device. The tributary flow, the stream flow, this is my colleague Evan, a grad student. He's measuring right now the stream flow. There's a little pinwheel at the bottom of that stick, and it measures how fast the water is going past him. We tend to do this only after a large rain event. We don't do this as normally, so it's more of an event sampling. And then you can see him with Paige going out enjoying their new waders for it, and just kind of seeing what they're finding like by this culvert. And then the one device that we really like is the LidaTrap. This is the device that goes inside the storm sewers. And we currently have 9 of these installed. 6 in the city, 3 in the suburbs, 5 in residential housing areas, 4 in more commercial shopping areas for it. And so this goes under the grate, and this goes underneath. So we sweep everything from the grate in, and then we push it in, and then we weigh it, we empty it, then we do the empty weight to get the wet weight of all the material. Then our trusty grad students go back to the lab. We put it in a drying oven, which makes it a lot less gross, and that also kills any bugs or bacteria on it. And then they end up sorting it. So I've done this a few times. The drying ovens help so much with dealing with the grossness for it. And we're again looking just for the macroplastic. That's what fits through this. So this is a 0.5 centimeter mesh. And then we're doing it over a screen that also has 0.5 centimeter mesh. So we're just looking for the bigger items. And then we're sorting it by category and material. And so this is one LidaTrap, so this would be a 2-week period. You can see there's a lot of wrappers, some properties for it. This sample, and this one was from a different 2-week period, is outside a convenience store in the city. And one thing we found, it's not people making bad choices necessarily. There is a trash can right next to this storm drain that is almost always full. And so trash falls out, it blows out. People are trying to make good choices. We actually had a woman talk about how since we started this project, she's been telling her friends not to put needles down the drain, because a lot of people were putting them down because they saw it as a safer place. They wanted to make sure that none of these needles fell out in a place where a kid could touch them. Or if someone went to look for returnables, they wouldn't get stabbed. So people are trying to make good choices. It's that the system isn't set up to help them. And we've also found a complete uneaten hot dog is one of the weirder things that we found for it. And I think one of the big things that we realized is how much organic, how much leaves and grass that goes down it. And we always knew that it was a lot, but even the sites with a lot of plastic are still about 95% organic, which seems good because it's natural. But as those leaves and grass break down, it adds nutrients. So you get all those algal bloom issues that I'm sure you guys are all aware of for it. And part of why we're doing this research is we have a lot of models, but we haven't had a lot of concrete data. We've been doing this for a year so that we can have actual numbers to base our different models from. And also we can talk to the city and the county and be like, all this grass and leaves are an issue. Like, you have to deal with this much. Two of our grad students, Paige and Jay, realized about 130 grams of material are going down each storm sewer per day on average. And there are 30,000 storm drains in the city of Rochester. So that tells you about how big a problem this is. We're finding a lot of variability in the composition. There's also a lot of seasonality that we're finding. So more, we tend to find more in the summer than the winter. Cigarette butts are the highest identifiable item, but there are less of those in the winter. That's one thing also when we do our litter cleanup. It's always a tie, neck and neck. Are we gonna find more wrappers or more cigarette butts? And usually cigarette butts come out on top, unfortunately. So that also ties into how public health kind of goes in with this. So again, a commercial site for it, and then residential. Here's another residential sample. So we're finding some waste. It's a lot less, usually because people are just walking by residential sites less. They're not, it's just more spread out. But again, we're still finding plastic. And in the suburbs, there's less foot traffic. We find less plastic, but we still find some. That we haven't had a sample with no plastic in it. We're always getting some. And what can we do? So based on the types of microplastic that we're finding in the oceans, we know that the top source is textiles, is fibers. And then the next one is tires, is tire dust. We often think of, we all know that every so often we have to replace our tires because they wear away. We don't often think about what happens to the material that gets worn away. But all of that, the rubber on the tires with all the different additives are a type of plastic, and that enters the environment. We have city dust, road marking, and then in the oceans, we got the protective marine coating, personal care products, and pellets, things that were made small for it. And one thing to realize is that plastic pollution is a fossil fuel issue. As we use less fossil fuels for energy, fossil fuel companies are looking for other ways to use their fuels. And one of the things they can do with them is make plastic. So these companies have a vested interest in making sure we use a lot of plastic, even as we turn to more renewable energy. And so some of the things we can do is, when possible, try to get clothes with natural fibers, just because when they degrade, they're more likely to fully break down. And also they tend to make larger fibers that aren't as released in the environment. And then the other thing you can do is change how you do laundry. Putting filters on your washing machine. So I have a washing machine that empties into a utility sink. The old nylon stocking over the end. It'll make a difference. Think about all the material you catch in one of those. And realizing that drying your clothes makes 4 times more microfibers than washing them. About 120 million microfibers come out of the wash. Come off out of a load in the dryer. And some of that gets caught in your filter, the lint that you take out, that's all microplastic. But some of it goes in the exhaust, goes into the environment. Avoid using the delicate setting when you can, because it uses more water than a normal cycle. Washing your clothes less often. And then buying less new clothes, because new clothes shed more when they're first washed. Over time, items shed less for it. And I realize that everything I mentioned depends on your situation. There's not one magic bullet that any of us can do. When possible, avoid single-use plastics. I think one of the big ones is if you're gonna get takeout, if you're gonna eat it at home or somewhere where you have silverware, make sure they know you don't need silverware in the bag for it. You know, swapping reusable for this, using reusable items instead of just disposable. If you can find some zero waste grocery stores that allow you to bring in some of your own containers. There's one that just opened in the city where you can get cleaning supplies in bulk, where you can bring your own jar for it and fill it up. And microbeads are now banned for it. There was a law passed in 2015, but you can still find them in products, especially ones that you buy online that may have a foreign source, because the law that banned it was just in the US. So looking at different ingredients for it. And then trying to limit the plastic that gets in us. On average, we all eat about a credit card's worth of plastic a week. And most of the plastic that goes in, honestly, we tend to poop it out, but we don't know the long-term health effects. Our group at RIT is looking more at how plastic enters the environment. I know other researchers, especially at the U of R, are looking more at the University of Rochester, are looking more at the public health side of it. So there's a lot of different scientists looking at all these different puzzle pieces of this issue. So reduce shellfish consumption. Because of where shellfish live in the bottom, they tend to have higher concentrations of microplastic than other animals. And one of the big things is don't microwave your food in plastic. If a container says microwave safe, all that means is that it won't melt in the microwave. It doesn't mean that it won't transfer chemicals or plastic to your food. So when you get those bagged vegetables that are like the cook in the bag, I always like open them up and like put them in a glass container to heat it up in. It's an extra step, but it does make a difference. And then regularly dust and vacuum. About 39% of the dust in your home is microplastics. So the more you can deal with the dust, the less microplastics around you. You can use different air filters. Make sure to change your furnace filter when you can. Hard flooring is better for this over carpet. This carpet's made of plastic, and that will put fibers in the air. And realize this is bigger than any individual. As I said, in the 1970s, a lot of the early environmental movement put a lot of the focus on individuals. But a lot of these issues are bigger than what one person can do for it. So I'd say trying to work together, be part of organizations that care, learning more of what we can do with large collective action for it. So thank you. Our funding for a lot of this comes from the New York Sea Grant and NOAA for this. And here's my email. And if there are any teachers or if any of you know teachers out there, I have a whole plastic pollution curriculum. And as I said, Churchill Chali Middle School made a whole formatted unit on plastic and microplastic for 6th grade, but it can probably be adapted up or down a little bit for it. So I know I just threw a lot at you. And again, I'm the outreach specialist, I'm not the scientist. So if you have a technical question I don't know the answer to, I'll ask my colleagues who are experts for this.
Do you give presentations in schools, or do you just assist with curriculum?
So I do give presentations in schools, I do go in, for it. This picture was actually from a week and a half ago when we were at our center. We're doing an activity on, water treatment for it. So I do both go in, but I know that if I can reach a teacher and we can share materials, that it can really expand out what I can do, just myself. Anything else?
Yeah, I have a question. I take my garbage to the local transfer station.
Yeah.
And I sort out the plastics,
Mhm.
all that stuff, like they tell you to do. Is that very effective in reducing pollution, do you think?
It depends. And different recycling systems have different pluses and minuses for it. And I think it helps a little bit, but obviously the quality of the system matters a lot. And then it also matters the market for it, because recycling centers are really people that are gathering materials to sell as raw materials to other places. So it depends on the overall market. When fossil fuel is more expensive, it's then cheaper to turn to recyclables. When fossil fuels are cheaper, it's easier to make fresh plastic for it. So a lot of it depends, and certain systems are more effective than others. So it's a big question. And then I would say, look at what your local recycling system, what they take in and what they recommend. Different areas have very different rules about what you can and can't recycle, and you don't want to wish cycle. So often people put it in the recycle bin because they wish it could be recycled. But as our local eco park says in Monroe County, when in doubt, throw it out. Because if you put an item into the recyclables that can't be recycled, it can taint a whole area. For a fact, I know that in Monroe County, those clamshells that hold berries and things like that cannot be recycled, because the machines that sort out the cardboard squish it and treat it like cardboard, and it could actually taint the cardboard, so then the cardboard can't be recycled because there's plastic mixed in.
On the chat room, see those?
Yeah, I can turn that on. Are there any adult volunteer opportunities to assist with cleanups? In Monroe County, I know that we work with the Seneca Park Zoo, has at least one cleanup a month, and more frequently. All the zoo cleanups are actually part of this research. They sort every item that they have. And one other thing that's cool is when we collect trash at those, they put them in the giraffe feed bags. So we're not putting plastic pollution in plastic. We're actually putting it in paper for it. Because obviously the zoo goes through a lot of herbivore feed for it.
Katie, the Conesus Lake Association holds their annual cleanup on Saturday, April 20th, if you want to say
Okay,
that.
so the Conesus Lake Association has their cleanup on Saturday, April 20th, as part of Earth Week. I'm sure there'll be many more informations for it. Also, if any of you are part of a scouting group or a Girl Scout group and are interested, we have a patch that we made. And I have a guide if you want to do the citizen science cleanup with the sorting and the data that you collect, RIT can use to help with this knowledge for it. Let's see. Are wastewater treatment plants effective in removing some level of microplastics? The big question there is some. They can do some, but not all. And we know that the nanoplastic is really too small. With the article that came out from the bottled water, they're actually finding a significant source of the nanoplastic was actually from the filters themselves. That as some of the filters degraded over time and broke down, and added plastic as they were removing other things. Because we're talking about really minute levels of plastic. This is the kind of plastic that a colleague at Cayuga College, I'm blocking on her name, has been looking at the precipitation, the nanoplastic in it, and found every liter of rainwater has between 550,000 pieces of nanoplastic in it. So when you see those like big drenchers covering a parking lot, realizing that it's just a plastic soup, it's kind of scary for it. And then let's see. And then there's more information on the Livingston County Environmental Management is holding a cleanup day on April 13th through the 21st, and the CLA is organizing a group for this event. So the email is in the chat. Any other questions?
Katie, can you hear people online?
What? If you're online, if you could put your question in the chat.
Okay.
Yeah. Chris?
You mentioned there's a store in Rochester that's selling bulk cleaning supplies and things like that.
Yes, it's on South Ave. It's Marilla has it, and I know Abundance Co-op also on South Ave. There can be more. There might be more. They're just in my neighborhood, so I know about them. They sell cleaning products where if you want, you can bring your own container. They'll weigh the empty container in the front, and then you can fill yours and take it out, so you don't have to use plastic to hold it for those items. Yes.
I have a question on the, I guess, the studies or the sampling that RIT has conducted
Yeah.
in the various. Is that, I guess, are there plans to continue that? Is there a window where that stops, or is there another step?
This is looking, the audience just asked about the long-term sampling plans. Currently, we are planning on continuing this. We are going to go a little longer between sampling events. So instead of doing it every 2 weeks, we're going to do it monthly. We know based on the devices for the Lititrap that there's enough room in the basket to be able to do that. We are also working with the Rochester Museum and Science Center, the Center, Seneca Park Zoo, the Edgerton Rec Center, the Ryan Street Rec Center, and Nativity School on Gregory Street in the South Wedge. At all of those locations, we're going to be adding 2 Lititraps there, and we're going to be adding that to the sampling location. And the ones at our centers and the school, we're going to have the youth and the students help us with the sampling. And we're working with a local marketing professional that's going to help us have the students come up with outreach materials to really hyper focus on their local environment to see like what kind of plastic are we finding in the neighborhood and what kind of messaging would be useful at that level for it. Yes, to the EMC posting links on the website for more of this. If you email me, I can share more materials with you for
I
this.
can put you in touch with Mary.
Yeah. Okay.
Other questions, comments?
I know this is easy to get kind of just overwhelmed with, and we all I think we all have our plastic sins. As you saw, I have 2 young children. We use disposable diapers, and we use so much plastic involved in it, and you make the better choices when you can. And I really don't want to tell people to like buy certain things or force people to do them. I'd say make the steps that you feel comfortable with, and then support the large scale change that we need to make a better community for all of us.
Well, okay, thank you very much. And on behalf of the Conesus Lake Association, I have a certificate of appreciation. We want to
Yes.
present this to you. And again, thank you for coming out tonight. A great presentation.
Thank you for having me in this wonderful facility.